first thing I want you to notice about these problems is how different they are from the last problems we were given. In this problem, we're solving for theta. So our answer should be an angle. I want to know what is the angle that solves this equation. Whereas before, up here, we plugged in an angle and our answer was a point. So in this problem, I'm given the opposite. I'm given that the point is 1/2, and I want to solve what angles I can put into there. So basically what this question is asking is, what angles can I plug in to get a cosine value of 1/2. What angles can I plug in to get a cosine value of 1/2? Now, we know that cosine is just another word for the x value. So instead of saying what angles can I plug in to get a cosine value of 1/2, let's change this to what angles can I plug in to get in a x value of 1/2. So I'm going to think of my unit circle here. Here's my unit circle. And I'm trying to think of where on this unit circle is the x value, or the cosine value, a positive 1/2. So we want the x side of the triangle to be the shorter side of the triangle, 1/2. So that would put us right here at this triangle, because that's where the x value has a shorter side of 1/2. But there's also another place on the unit circle that has this same x value. We also have right here. This triangle also has the same x side of a positive 1/2. Now, I could also do this triangle over here. That has a shorter x side of 1/2, except notice that x side is actually a negative 1/2, not a positive 1/2. So I actually do not want that triangle. So I have two triangles here that give me an x side of 1/2. I need to figure out what angles go with these triangles. So we have to think of our unit circle. I would like you to get used to putting your angles in radians, not degrees. You probably quickly saw, hey, this is 60 degrees, but I don't want you to get used to degrees. I want you to start practicing with radians. So instead of saying 60 degrees, we say this angle is pi thirds. And this angle down here is going to be 5 pi thirds. So I have this angle to pi thirds. And I also have this angle to 5 pi thirds. Now, I do also want you to notice that another way of writing this 5 pi thirds, I could also say negative pi thirds. So if I go clockwise to this point, that gives me negative because we're going in the clockwise direction, and I go pi thirds in the clockwise direction. So the angles that are giving me this correct cosine value, or this correct x value, are pi thirds and 5 pi thirds. Or you could use negative pi thirds here as well. That's the same thing. They're coterminal angles. However, be careful if you're wording this problem. This problem says find all of the angles which satisfy the given equation. These are two angles that I can plug in here and make the equation true. Cosine of pi thirds equals 1/2, and cosine of 5 pi thirds equals 1/2. However, there's a lot of coterminal angles that I can also plug in here to get 1/2. We already saw one example, negative pi thirds. I could plug negative pi thirds into here to also get 1/2. So what we're going to do here is expand the angles we picked to include all of the coterminal angles. Now, if you remember when we did coterminal angles, we said coterminal angles are always one full circle apart. We get a coterminal angle by either adding a whole circle or subtracting a whole circle. So what we're going to do is say that all our coterminal angles are one whole circle apart from these angles I have listed. And I'm going to put a K here. And K is how many times we go around the circle. So if K is positive 1, then I'd get pi thirds plus 2 pi. That's a coterminal angle. Or if K is a negative 1, then I'd get 5 pi thirds minus 2 pi K. There's my negative pi thirds. So just adding this 2 pi K thing at the end, that is now getting us all the angles that we can plug into this equation. So that is our final answer. So at the end of the day, essentially, we're just adding 2 pi K to the angles we get here to account for all our coterminal angles. So let's try that with another one. This one, I have sine of theta equals negative 1/2. So this one is asking, what angles can I plug in to get a, now this one, because it's sine, I don't want an x value, I want a y value of negative 1/2. So I want to find where can I get a y value of negative 1/2. So once again, think of our unit circle. I want the y value to be negative 1/2. So that's just another way of saying I want the y side of the triangle to be shorter. And it needs to be in the negative y direction. So that's going to be here and here. Because both of these triangles have a shorter negative y side. So this has a y value of negative 1/2. This has a y value of negative 1/2. So I get this angle here, and I get that angle there. So let's list them. This first angle is going to be 7 pi 6, and this second angle is 11 pi 6, or if you thought of going in the clockwise direction, that would be negative pi 6. Now, once again, I want all angles. So I'm going to take the angles I got, or you could use negative pi 6 right there, and I'm going to add 2 pi k to account for all my coterminal angles. And then this is a list of all the angles that I can plug into this equation to solve it. Last one for this video. We now want to know where the cosine theta, so what angle can I plug in to get a, since this is cosine, we are looking for an x value of 0. So look at our unit circle, and we want to know where is the x value of this unit circle going to be 0. Well, that actually is going to happen at two places. I have this one right here. This has an x value of 0 and a y value of positive 1. And I have this one down here. This one has an x value of 0 and a y value of negative 1. So I have this angle and that angle. They both have an x value of 0. Now remember, I still got to do all angles. So I need to figure out what these are and then add 2 pi k to it. So this first one is at pi halves. And this second one is at 3 pi halves. Or you could think of it as negative pi halves in the clockwise direction. Both would be same. Both would be fine. And to make it all angles, I add my 2 pi k to account for all my coterminal angles. And we're done. Those are all the angles I could plug into there to get this equation to equal 0. So that is how we go backwards on equations. We're finding angles to give us points instead of plugging in angles to find the points. In the next video, we'll do the same thing, but we're going to expand it to more than just sine and cosine. We're going to start to look at tangent and secant and all those other ones.